We're introducing the graphs of exponential functions, and we're going to focus on the two cases, one where the growth factor is greater than 1, and case 2 will be when the growth factor is a fraction. Let's recall that the growth factor does need to be a positive value that's not equal to 1, and both of these cases satisfy those requirements. Let's also recall that the domain of an exponential function is all real numbers, so we can really choose anything we want to plug in to x. Let's focus our attention on some domain elements that are relatively close to the origin. And the function that we're graphing is y is equal to 2 raised to the x power. So when we plug in x is equal to -3, this is going to be 2 raised to the -3 power. As a reminder, 2 raised to the -3 is the same thing as 1 over 2 cubed, which is 1 over 8. So our output here will be 1/8. When plugging in -2, we're going to get 2 raised to the -2 power. 2 raised to the -2 is 1 over 2 raised to the +2, or 1/4. So our output value here is 1/4. When we plug in -1, we're going to get 2 to the -1, and 2 to the -1 power is 1/2. So our output value here is 1/2. When we plug in x is equal to 0, we get 2 to the 0, which is just 1. When we plug in x is equal to 1, we get 2 to the first power, which is 2. Plugging in x is equal to 2, we get 2 squared, which is 4. And plugging in x is equal to 3, we get 2 cubed, which is 8. So let's plot each of these ordered pairs. We have -3 corresponding to 1/8, -2 corresponding to 1/4, -1 corresponding to 1/2. We have the ordered pairs 0, 1, 1, 2, 2, 4, and 3, 8. And when we connect these dots, what we'll see is an increasing exponential function that will actually be approaching the x-axis as an asymptote. The x-axis is the equation y is equal to 0, and our exponential function will get infinitely close to that value, but will never actually arrive there. So let's make note of the fact that this is an increasing exponential function, and we'll formalize some of these characteristics. When we have an exponential function that has an initial value of 1 and a base or a growth factor that is greater than 1, we know that the domain is going to be all real numbers because it's an exponential function, and the range of this function turned out to be from 0 to positive infinity. Remember, the horizontal asymptote was y is equal to 0, and then the graph was increasing from that point. We didn't have any x-intercepts, and the y-intercept turned out to be the ordered pair 0, 1, which makes sense because when we plug in 0 for x, we get a to the 0, which is 1. Notice that 1 was also our initial value. One of the important things to notice here is that when that growth factor is positive, we're going to end up with an increasing exponential function. It's not decreasing or constant. The graph of our exponential function is going to contain the ordered pairs 0, 1. When I plug in 1 for the x value, we're going to get that growth factor, whatever it was, as an ordered pair on the graph. And when the domain element is -1, and we plug -1 into the function, we're going to get the reciprocal of the growth factor as an output. And these two ordered pairs will be on our graph. We also want to make note of the fact that this exponential function does pass the horizontal line test, and therefore it is going to be a function that's 1 to 1. Let's notice on our graph that we do have the ordered pair -1 corresponding to the reciprocal of the growth factor, 0 corresponding to the initial value, and +1 corresponding to the growth factor itself. Our graph was increasing. It does have a range from 0 to positive infinity, with y is equal to 0 as the horizontal asymptote. Let's take a look at another case now where the growth factor is a fraction. Greater than but not equal to 0, less than but not equal to 1. Again, we'll focus our attention on the same domain elements. Remember, the domain is all real numbers, so we can plug in anything we want for x. And this time we're taking 1/2 and raising it to the -3 power. Let's notice that 1/2 raised to the -3 is the same thing as 1 divided by 1/2 raised to the +3. 1/2 to the +3 power is 1/8, and 1 divided by 1/8 is the same as 1 times 8 over 1, which is 8. So -3 as the input corresponds to the output, +8. Now let's plug -2 in for x. We'll get 1/2 raised to the -2 power. 1/2 raised to the negative 2 is 1 divided by 1/2 raised to the positive 2. 1/2 squared is 1/4. And when we divide fractions, we keep the top, we flip the bottom, multiplying by the reciprocal of the denominator to get 4. So 4 is the corresponding output here. When we plug in -1, we'll get 1/2 raised to the -1 power, which can be interpreted as just the reciprocal of 1/2, which would then be positive 2. A little shortcut here. So our output is 2. When we plug in x is equal to 0, anything to the 0 power is 1. When we plug x is equal to 1, we get 1/2 raised to the first power, which of course is just 1/2. Plugging in x is equal to 2, we get 1/2 squared, which is 1/4. And plugging in x is equal to 3, we get 1/2 cubed, which is 1/8. So now let's plot these ordered pairs on our graph. We have -3, 8, -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4, and 3, 1/8. Notice again we're getting infinitely close to the x-axis, but we won't actually reach it. And this time we have a decreasing exponential function that is again approaching the line y is equal to 0, the x-axis, as a horizontal asymptote. Let's notice again that we're looking at the case where the initial value is +1, and that when we plug -1 in as a domain element, we get the reciprocal of the growth factor as an output. And when we plug +1 in, we get exactly the growth factor as an output. Notice as well, the range of this exponential function is from 0 to +infinity, and the domain is all real numbers. Let's formalize that in our table for the characteristics. So when we're looking at an exponential function where the initial value is equal to 1, and the growth factor is a fraction in between 0 and 1, we can say that the domain is going to be all real numbers. The range was from 0 to +infinity. We didn't have any x-intercepts, and that was because there was a horizontal asymptote at the line y is equal to 0. The y-intercept was 0, 1, which was corresponding to the initial value. A key takeaway here is that when the growth factor is a fraction, we're going to end up with a decreasing exponential function, not increasing or constant. We noticed above that 0, 1 was a point on the graph, and the domain element 1 is going to correspond to the growth factor, and -1 corresponds to the reciprocal of the growth factor. These 3 points are on our graph. Again, our exponential function is 1 to 1, and we'll just notice for now that it passes the horizontal line test. And these characteristics are going to hold true for any exponential function whose initial value is 1 and whose growth factor is a fraction.